You're sitting somewhere, maybe in a small room, a delayed train car, or a place no one knows about. The space around you is so quiet you forget it's even there. Time flows as usual, no one mentions it, but you can still hear its rhythm, somewhere between two breaths. We live in space guided by time, yet we rarely stop to ask, what are they, really? Does space have a shape, a color, a boundary? And what about time? Does it flow or drift? Does it exist? Or is it only a feeling? These might sound like questions for philosophy, but science can't look away. When physicists began measuring and exploring the universe, they couldn't avoid brushing up against the very foundation everything rests on, space and time. But the deeper they dug, the blurrier things became. Space was no longer flat. Time was no longer steady. And then both dissolved into each other, forming something called spacetime, something that could bend, twist, shift. The simpler the question, the more the answer slips away like smoke. Maybe it's because we're asking the wrong thing. Or maybe we're trying to see what can't be seen, trying to catch what never stays still. So let's try, just once, not to search for answers, but to follow the question. Gently, like walking through a dream, where everything feels right, even when we don't know why. Tonight, I invite you to sit down, slow down, and step with me into a place where space and time are only ideas. Because sometimes, the things we're most certain of are just a thin mist covering reality. If you close your eyes and imagine every sound fading away, every image going dark, every motion coming to a halt, what's left behind isn't emptiness. It's space. Space doesn't need shape to exist. It doesn't need anyone to witness it. It's simply there, like a silent backdrop, waiting for everything to come and go. And time always passes quietly, leaving no trace, asking no permission. Even when no one is watching, it still flows. Strange, isn't it? Two things that are always present, always affecting us, yet they're the very things we can't touch, can't hold, can't describe precisely. You can draw a chair, a house, a sleeping cat, but you can't draw space. You can note an appointment time, mark an afternoon, count the years that have passed. But you can't grasp time like you'd hold a flower petal. We're born living inside them, like fish in water. And like fish, we rarely question what surrounds us. But humans are curious creatures. Even if we can't see space or time, we still find ways to express them. With clocks, with maps, with coordinate axes, rulers, reference frames. We use them to pinpoint an object's location, to meet each other, to recount what happened, to dream about what might come. We use them as if they're real. But are they? The ancient Greeks once believed time was a circle. Everything repeated, like the seasons, like the moon waxing and waning. To them, the universe didn't progress. It cycled. The Indians went even further, seeing time as a sequence of grand epochs, each lasting billions of years before everything resets again. Meanwhile, Western philosophy from Augustine to Kant was more puzzled. Augustine once said he knew what time was, until someone asked him. And Kant believed that time and space weren't out there, but rather the way our minds organize reality. Just as eyes need light to see, our minds need space and time to comprehend. So are we living in reality, or just in an interpretation of it? When physics was still about swinging pendulums and colliding balls, people thought of space as an invisible box that held everything, and of time as a cosmic clock ticking in the background. Newton called this absolute time, untouched by anything happening inside the universe. If you dropped something today or 1,000 years from now, to him, time would still tick along at a steady pace, never missing a beat. It made sense. It helped us establish the laws of physics, build accurate clocks, create a whole technological world. But the deeper we went, the more something felt off. Because if time is truly absolute, why do some moments feel faster or slower? If space is flat, why does light bend when passing near a star? Gradually, people began to realize that maybe space and time aren't unchanging. Maybe they aren't the foundation, but the result. Maybe, if nothing happens, time doesn't exist. Maybe, if no one is looking, space means nothing. That's not just speculation. It's what modern physics, from Einstein to quantum theorists, has been increasingly showing. Space can curve if there's enough mass. Time can slow down if you move fast enough. Near a black hole, a minute can be a lifetime somewhere else. If you're standing at the base of a mountain, time runs slightly slower for you than for someone at the top. Just by a fraction of a trillionth of a second, but it happens. So if time can stretch, shrink, be influenced by matter, does it really exist as something on its own? Or is it just how the universe responds to change? From here, the story gets even stranger. Some scientists believe that neither space nor time is fundamental. They're just side effects, emergent features of deeper structures we haven't yet seen, like a fabric woven from countless threads. But all we see is the pattern, not the threads. One physicist once said, "Space might be woven from information." If that's true, then our sense of space, of distance, of coordinates, is just an illusion created by quantum relationships between the smallest pieces of reality. And time? It doesn't flow. It doesn't move. There is only change. And from that change, we feel time. But if time is a result of change, what changed first before there was time? That question is like trying to bite your own shadow. But sometimes, it's those very questions that give us the clearest sense of how deep reality runs. You might be sitting still right now, thinking you're not moving, but you're spinning around Earth at thousands of kilometers per hour. Earth is orbiting the sun. The sun is drifting through the galaxy. Everything is in motion, and if something isn't moving, we'd never know because every measurement needs a reference point. Space and time on their own can't be detected. Maybe the only thing that makes space and time real is that someone is living inside them. So perhaps space and time aren't objective things out there. They're interactions between objects, between perception, between feeling and phenomenon. They're not like floors and clocks. They're like the air we breathe, always present, but never still. And of all the things we know, maybe space and time are the most familiar yet most mysterious. Because they're both the stage where everything happens, and themselves part of the unfolding. Maybe space has no shape until you reach out your hand. Maybe time doesn't flow until you think about tomorrow. Maybe, just maybe, it's only when you close your eyes and breathe slowly that space and time appear most clearly. Not in theory, not in equations, but in the very stillness of a single moment. In the 17th century, when Newton introduced his ideas, he wasn't just describing motion, he was rewriting the entire language of the universe. In his view, the world was a vast clockwork system where everything had a cause, and every cause led to an effect. Space, to Newton, was an absolute frame, a hidden stage upon which every physical play unfolded. Time was the background clock, silent yet essential, ticking steadily for the entire cosmos. Newton didn't do this on a whim. He had to assume an absolute space because, without it, there would be no way to define real motion. An object could only be said to move if there was something fixed to compare it to. Without that unchanging background, motion would be just an illusion, a relative change, not something truly real. Newton wanted the universe to have an absolute frame of reference, a foundation that could not budge, because if the foundation itself moved, then nothing could truly be said to be moving at all. But this is where philosophy began to whisper doubts. The philosopher Leibniz, a contemporary of Newton and also his intellectual rival, disagreed with that idea. He believed space wasn't a real thing but merely a relationship between objects. If there were no objects, space wouldn't exist. The same went for time. It was just the order of events, not an objective flow. For Leibniz, space and time weren't the backdrop, but the way we describe how things relate to each other in the universe. These debates went on for decades and then faded into silence. Because the truth was, Newtonian mechanics still worked incredibly well. It helped launch cannons, build bridges, steer ships, and carry humanity into the Industrial Revolution. Who needed philosophy when you could build factories? Then, toward the end of the 19th century, a new idea emerged, the possibility of a medium in space called the ether. something through which light waves could travel the way sound travels through air or ripples through water. If you drop a pebble into a lake, you see waves spreading out, and if you're swimming, you'll feel the wave's speed change depending on which way you move. Ether was imagined just like that. A hidden field, filling all of space, acting as the medium light needed to travel. That idea seemed reasonable. But when Michelson and Morley tried to measure whether Earth was moving through this sea of ether, the result they got was nothing. Light always traveled at the same speed, whether you were moving with or against Earth's rotation. No difference, no ether wind, no trace of that invisible foundation. This was the first blow to Newton's absolute stage. If ether didn't exist, then what was light traveling through? And if the speed of light didn't change depending on who was observing it, then maybe space and time themselves were hiding something deeper. That's when physicists began to suspect that space and time might not be as absolute as Newton had thought. But instead of throwing his legacy away, they looked for ways to adapt it, to bring it in line with the evidence. One of the first efforts came from Lorentz, who proposed that objects might shrink when moving fast and their time might slow down, but that this was just a surface effect, a kind of illusion created when objects moved through the ether. Lorentz was trying to save Newton's foundation by putting a mask on it. But then, a young man came along who refused the mask. Instead of defending the foundation, he asked, if the speed of light is always the same and everyone measures it the same way, then could it be that space and time themselves are changing? That question might sound simple, but it demanded a massive shift in thinking. Instead of believing in a single shared clock for the entire universe, this person dared to imagine that each person has their own. Each frame of reference has its own time. No more absolute time. No more unchanging space. When you believe in an unmoving stage, you believe every actor is just part of a picture already drawn. But when the stage starts to move, when it stretches and bends and reacts to the footsteps on it, the play no longer follows a script. Everything becomes relative. And to accept that, you need a mind unafraid of loneliness, unafraid to break what once felt eternal. A mind like Einstein's. But even before we enter Einstein's world, let's take one more look at Newton's stage. Though it cracked under the light of modern science, it was still a masterpiece. It let humanity, for the first time, predict the universe. From the fall of a bullet to the orbit of the moon, everything became calculable. The world was no longer ruled by chance, but by consequence. Space was no longer empty, it was a framework for law. Time was no longer vague, it was the heartbeat of a rational universe. Maybe that's why it's so hard to let go of it. The idea of a reality that can be measured, predicted, and understood by human intellect gave us the feeling that we're not lost. That we can know, we can map, we can master. But light disagreed. And from that tiny crack, the entire picture began to fracture. The world used to be a clock, steady, tidy, ticking to the rhythm of an invisible mechanism that Newton called laws. But then, like every classic mechanical clock, it began to drift. A few tiny details, deviations that once seemed meaningless, forced the entire picture of physics to look back on itself. And in the moment light refused to behave as Newton predicted, a young man with messy hair and thoughtful eyes began rewriting the structure of reality. Albert Einstein was not a loud revolutionary. He didn't shout that Newton was wrong. On the contrary, he loved the laws of mechanics, the precise predictions, the sense of order Newton had established. But he also had a dangerous habit, asking questions. Questions so obvious that others no longer saw them. Like, why does everyone measure light moving at the same speed, whether they're standing still or flying through space? Or, if I chased after a beam of light, what would I see? His answers weren't just theories. They turned the entire foundation of physics on its head. With special relativity in 1905, Einstein declared that there's no single clock for the entire universe. Each person, each object, each moving frame of reference experiences time differently. Time was no longer a universal flow. It could stretch or shrink, speed up or slow down, depending on how fast you were going. Picture a pair of twins. One stays on Earth. The other boards a spaceship, travels close to the speed of light, and returns. When they reunite, something strange happens. The traveler is younger than the one who stayed. Not because of diet or lifestyle, but because they lived through two different timelines. This isn't just a thought experiment. It's been proven, measured, confirmed from GPS satellites in orbit to experiments with airplanes and atomic clocks. And if time can bend like that, space can't stay untouched. Einstein went further in general relativity, completed in 1915. There, he didn't just say time and space change. He said they are inseparable, one thing called spacetime. And spacetime isn't a silent stage like Newton once imagined. It's a stretchable fabric, a kind of mattress that can be warped by the objects resting on it. Earth orbits the sun not because the sun pulls it with an invisible string, but because spacetime around the sun is curved. Earth is simply gliding along a dented surface. Light passing near a massive object will also bend. And this, remarkably, was proven during a solar eclipse in 1919, when starlight shifted just as Einstein had predicted. Space was no longer flat. Time no longer ticked evenly. And more importantly, neither were silent spectators anymore. They had become central characters. Imagine a calm lake. In Newton's model, objects drift across its surface like leaves, interacting with each other, but never affecting the water itself. In Einstein's model, every object is a stone dropped onto the lake, warping the surface, creating ripples that influence everything else. Spacetime is now that lake, an invisible ocean being distorted by mass, energy, and motion. The idea was too big, too bold, and too accurate. It explained the strange orbit of Mercury, something Newton couldn't. It allowed us to predict black holes, gravitational waves, things once thought to belong only in science fiction. It turned Einstein into an icon, but also made many uneasy. Because if space and time could shift, what foundation was left? The feeling of losing your footing, your frame of reference. Something eternal is real. But from that point on, physics entered its most beautiful era. A time when everything could change. And because of that, everything could be understood, if we're brave enough to ask again. Space-time isn't just curved anymore. Can vibrate. When two black holes collide, they distort space-time itself, creating gravitational waves that ripple across the cosmos. These waves were so faint that it took a century before we could detect them. But when LIGO picked them up in 2015, it was another moment Einstein was proven right. And the applications are everywhere. Using GPS? Thank Einstein. Because if we didn't correct the clocks on satellites to account for time dilation from their speed and altitude, the map would be off by several meters every minute. Within hours, you'd be led into a forest or the ocean, not your favorite coffee shop. The world is now a dynamic web, not fixed, not uniform. Every star, every planet, every person creates a small dent in space-time. And we're not moving through empty space, but across a surface bent by our own presence. This way of thinking forces us to reconsider even cause and effect. If time can slow down, if two people can live in different flows of time, then what is now? What does simultaneous mean? The answer: there is no absolute simultaneity. Everything is relative, depending on where you are and how you move. But that doesn't make the universe chaotic. On the contrary, it makes everything more harmonious if we accept that no viewpoint is central. Each person, each observation holds its own truth, and from the combination of those truths, the bigger picture emerges. Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." In his view, space-time is a seamless block, where every point, whether it's tomorrow or a century ago, exists somewhere in the three-dimensional structure of time and space. We're simply drifting through it, like a needle reading one moment after another on a reel of film. That idea stirs something deep. If everything exists at once, is time even real? Or just the mind's way of experiencing change? That question will take us further, into the worlds of entropy, quantum mechanics, memory, and emotion. But for now, pause and take a breath, because you've just traveled through one of the most elegant bends in the history of science. A shift not just in equations, but in the way we feel about our place in the universe. Space-time is no longer a silent backdrop. It's a main character, able to ripple, change, bend, even break. And on this strange map, you, with your body, your mass, your energy, are leaving your own dent. Small but real. You're sitting still, not moving, not going anywhere. But the truth is, you're flying. Not just because the Earth orbits the Sun. Not just because the Sun circles the center of the Milky Way. But because you, even when completely still, are drifting through time. You're constantly moving away from the past, second by second, like a silent astronaut gliding through space-time. And the strange thing is, the faster you move through space, the slower you drift through time. It's a speed game, and no one gets to sit it out. Imagine space-time as a four-dimensional fabric, and every creature as an arrow tracing a curve through it, a path called a world line. Even if you're not going anywhere, your arrow still moves forward because you're always traveling through time. And if you start moving, you're not just changing position in space, you're tilting that arrow. Less time, more space. The universe seems to distribute motion in a way that the total never changes. You can only move less through time if you move more through space. This isn't a metaphor. It's the actual math behind special relativity. A massive object can't move at the speed of light because to do so, it would have to give up all motion through time. Light, having no mass, doesn't flow through time like we do. For a photon, time doesn't pass. It's born, emitted, and absorbed, and to it, all of that happens at once. That might sound strange, but think of it this way. We're used to thinking we're here, in three-dimensional space, and time is the river we're floating on. But the reality is different. Space and time aren't separate. They're dimensions of the same thing. And every person, every object, traces their own path through that structure. You don't just live on Earth, you're carving a long line through space-time, moving a little farther from where you were each passing second. In that model, everything is always in motion. There's no such thing as true stillness. Because even when your space coordinates don't change, you're still moving into the future, and that's motion along the time axis. And just like in classical physics, the more you move in one direction, the less you move in the other. An object at rest in space experiences time at its fastest. But as it speeds up, time flows more slowly for it. And as it nears the speed of light, time nearly stops. That's why astronauts orbiting Earth age more slowly than we do. Because they're moving faster through space. They drift more slowly through time. The difference is tiny, just a few millionths of a second. But it's real time, not an illusion. Their bodies truly experience less time. And what does that mean? That you could save time by moving quickly? Or live longer by flying endlessly through space? Maybe, but at an enormous cost in energy and in loneliness. Space-time is like a map you never stop drawing. Every action, every heartbeat, every step leaves a trace that can't be erased. They remain like folds in an invisible sheet. And from any point on that map, you can only move forward. No one ever has gone back to a previous point because the universe doesn't allow space-time curves to loop. At least, not in our current theories. And here's another wonder. You're never on time or in space. You are a part of space-time. Your body has mass, has energy, and because of that, you slightly bend space-time around you. That means you're not just flying through space-time, you're also shaping it. Just a little, imperceptibly, but you leave an impact. You're creating ripples in the fabric of the universe. And that's not just physics. It's also a beautiful metaphor, that even if you feel small, still doing nothing special, you are flying. You are drawing a journey. And no matter how short or slow the journey is, it's still unique. Because no one else has your world line. When you walk, you're slightly accelerating. When you board a plane, you accelerate more. When you imagine flying to Mars, you're playing with the idea of time flowing differently. And that's no longer science fiction. That's math. That's reality. The more we understand this, the more the idea of the present becomes blurry. Because your present could be someone else's past, or someone else's future if they're moving fast enough. There's no single plane of now stretched across the universe. Each person has their own slice, a personal present based on how they're moving, that might make you feel lost. But it can also bring comfort, because in a universe where no one shares the same present, every present matters. Every moment you live is a unique point on a map no one else has ever passed. A dot that won't repeat, and you're leaving that trace second by second. The universe, in this view, isn't a still painting. It's a river with countless streams. Each person is a stream of their own, a fork, a gentle whirl in the ocean of spacetime. And once you realize that you are always flying, can't stop, can't go back, you may start to care more about where you're headed. No one can be still in spacetime. No one can escape it. But each person can choose how they fly, slow or rushed, mindful or numb, drifting or deliberate. And that's why spacetime isn't just where physics happens. It's where meaning can be written. Spacetime, as we know it, is the foundation of everything. It's where all motion happens, the container of cause and effect, of journeys and memories. In Einstein's world, it can bend, it can ripple, can be influenced. But what happens if you go further? If you step beyond Einstein's boundary and ask, is spacetime even real? At first glance, that idea sounds like a paradox. How can the most fundamental thing, the one we've always assumed to be a given, be just an illusion? But 21st century physics is starting to say strange things. And one of those things is, space and time are not fundamental. They're not the raw ingredients, but the byproducts. The outcome, an illusion born from deep quantum entanglement. Imagine a thick, soft, warm carpet. You walk on it every day. You think it's the floor. But then one day you kneel down, look closely, and you see, it's woven from tiny threads, twisted and tangled together. There is no carpet. There are only connections between strands. From that entanglement, the surface you call floor emerges. According to some physicists, spacetime is like that. The story begins with quantum mechanics, a realm where things no longer sit in fixed positions but exist as probabilities, distributions, and superpositions. In that world, the most certain thing is not location, but relationship. Who is linked to whom? Who is entangled with whom? In classical physics, you need spatial coordinates to describe everything. In quantum physics, it seems you only need to know what's tangled with what. And if you knew the full web of entanglement, then from that space would emerge. No need to predefine, this is length or that is time. Just quantum entanglement and the rest arises. The word emerges here is very specific. It doesn't mean just appears out of nowhere. It's how science describes something non-fundamental that arises from a system, like how temperature is the result of millions of molecules moving, not a property of any one molecule. If space-time truly emerges from entanglement, then it's like a hallucination we can feel, but can't touch at the most basic level. Some physicists go even further, like Juan Meldacena with his ADS/CFT model, or Eric Verland with emergent gravity. They suggest that gravity isn't a real force, but just the effect of quantum entanglement spread across space. Like how pressure isn't a thing by itself, but the result of trillions of gas particles colliding with the walls of a container. From this view, gravity and even space is just a mask. Some even argue that time itself isn't real, like Julian Barber, who proposed that the entire universe is a collection of frozen moments called nows. No motion, no flow, just different configurations of the whole universe, and your consciousness is sliding through those moments, like a needle reading each groove of a record. If that's true, then time, the thing we think of as a river, is really just an illusion made by memory. And space, the ground we think we stand on, is just an illusion created by the entanglement of particles. And if both space and time aren't real, then what is? The answer might be information. In many advanced models, the only thing that is truly real, unchanging, frame-independent is information. Every particle, every quantum state, every link carries information. And space-time is just the way that information gets woven together, arranged so it becomes stable, understandable, predictable. Like a story. If this makes your head spin, you're not alone. Even physicists admit we're stepping into unmapped territory. These ideas about emergent spacetime are still being tested, debated, expanded. But the fact that we even have to ask, is space real? Is time real? Already shows that modern physics is touching the deepest layers of reality. And in that place, you're no longer standing on a backdrop of space. You're floating in a tangled web of quantum states, where points don't have coordinates, but connections. Where things exist not because of their shape, but because of their relationship to everything else. You might imagine it like a Pointillism painting. No clear lines, no obvious structure. But when you step back, the dots begin to form an image. Space-time is that image. And your consciousness are part of the image taking shape. The strange thing is, if you change the way the dots connect, you can create a different space. Change the entanglement network, change the shape of space-time. This opens bold new ideas. Could we program space? Is the universe something like a giant quantum algorithm, where space is just the user interface? Maybe, or maybe, everything we're saying is just another metaphor for something we haven't named yet. Have you ever, on a quiet night, sat alone and looked up at the sky, only to feel so small you seem to dissolve? Not dissolve in fear, but in a peaceful kind of melting. When all the noise of the world fades away, and all that's left is the infinite emptiness above, where light from distant stars has been silently traveling for millions of years just to reach your eyes. That feeling, it's strange. As if you're standing at the edge of space and also right at its center. As if time isn't flowing, but unfolding. You're no longer thinking, no longer remembering, just present. In that moment, you're not just you. You're a point in space-time, a unique event where consciousness, matter, memory, and light intersect. And the question arises not in words, but deep enough to make everything else fade. Where am I in all of this? Maybe you think you are your body, a collection of atoms and molecules organized by DNA. But where did those atoms come from? They once lived in stardust, were born in supernova explosions, drifted through billions of years, and then became part of you. Space shaped you. And time, whether you notice it or not, has marked you in every cell. When you remember your childhood, you might think you're calling back a you from the past. But really, you're tracing your hand along the folds of space-time you yourself left behind. You're rewinding a piece of your world line, the curved path you once followed. But because consciousness isn't a camera, your memory isn't neutral. It tells the story, but it also rewrites it. It recreates, but always with emotion. Memory is not the past. It's the present, disguised as the past, told in your voice. And if time is a dimension of space-time, then memory is the heartbeat that makes you feel like you're moving in a direction. No one really knows what the present is, because everything we know takes time to reach us. Light takes time to hit your eyes. Nerve signals take time to travel. Consciousness, it seems, is always running slightly behind the real world. So when you think you're living in the now, maybe you're just living in a reflection. You're living in the shadow of light, in the echo of sensation. But that's what gives everything depth. Like how a beautiful piece of music is shaped not just by the current note, but by the lingering hum of those before. Consciousness is that music. It resonates through the universe, not in sound, but in feeling. And you, the creature listening to that music, are not just a passive receiver. You're the storyteller. Every action you take, every choice, every feeling alters the shape of the path you're tracing through space-time. You're drawing your own route by the way you sense and respond. When you love someone, it's not just a chemical reaction. It's the connection of two world lines, two journeys, two curves, suddenly coming closer. And there are people who may have only brushed past you for a moment, but left vibrations that echo for years. That means you have your own gravity. Not the kind that bends space physically, but the kind that bends memory, that curves someone else's perception. You're not a neutral observer in this universe. You're the one drawing the map of space-time by the way you live. And the strange part is, no map is correct, but every map is real. If space-time is the canvas, then consciousness is the artist. Walking forward, leaving marks. You don't need to know how big the canvas is, or why it has 4 dimensions, or whether it emerged from quantum entanglement. You only need to know that every step you take, every word you speak, every breath you draw, leaves a tiny dot on it. And if enough dots are connected, they form a shape. That shape maybe is you. Some say space-time is just a quantum illusion. Some believe it's the ultimate reality. But you don't have to pick a side. Because in the moment you remember a summer afternoon from your childhood, or stand beneath a starry sky, you don't need to explain. You just need to live. And that your ability to feel, to connect, to think, and to tell stories is how you touch the nature of space-time. You are a story, but not one written by someone else. A story you're telling every second, every minute in the way you see the world. Sit still for a few seconds. Do nothing. Don't think, don't remember, don't dream of the future. Just sit, and you'll notice something strange. Even without moving, speaking, or reacting, you're still changing, still moving. 1 second has passed, then another, as if the universe has its own clock that doesn't need you to check it. But what is that? Is it real time, or just a feeling? Is it the background of space you're in, or just a pattern your mind creates? That question has lingered ever since humans learned to ask. Is space-time real? If you asked Newton, he'd say yes. Space is the great container holding everything inside. Time flows steadily, regardless of who observes it. They exist like the stage of the cosmos, unchanging, neutral, eternal. And that model worked brilliantly. It built classical mechanics, sent humans to the moon, predicted planetary orbits. But then Einstein came along, and the stage began to bend. According to Einstein, space-time wasn't just a backdrop. It became a main character. It curved under the weight of matter. It stretched, rippled, and created gravitational waves. And that idea was so beautiful that, even centuries later, we're still listening for tiny ripples in the fabric of space-time, echoes from collisions billions of years ago. But quantum physicists didn't accept this so easily. To them, the world isn't smooth. It's grainy, jumpy, probabilistic, tangled. In their model, space-time isn't fundamental. It's just the way particles happen to arrange and relate. An emergent effect, a convenient mask for something invisible underneath. So here we are, standing between 3 worlds. In Newton's world, space-time is solid and real. In Einstein's, it's flexible and alive. And in the quantum world, it's like a mirage rising from chaos. 3 worlds, 3 visions, and none able to fully unite them all. But then you look at yourself. You remember a moment, dream of a future, feel the chill of an early morning, or the strange stretching of time while waiting for a message from someone you love. These things, you don't need equations to understand them. They don't need coordinates. No reference frame required. They just need you to live through them. And in those moments, maybe you believe in space-time more deeply than any physicist ever could. Space-time, illusion or foundation, is still the place where everything happens. And if it is an illusion, it's the only illusion everyone sees the same way. It lets events happen before or after. It lets things have causes and effects. It's the thread keeping the universe from falling into chaos. Maybe we've never truly touched real space-time. Maybe everything we know is just the surface of something far deeper, something no language can reach. But like children playing with sand on the beach, even without understanding the ocean, we can still see the waves, feel the wind, and hear the whisper of something larger than ourselves. And maybe space-time is that whisper. You don't need to answer the question, is it real? To live. Because every time you remember, every time you look up, every time you love, hurt, laugh, fear, you are confirming that you're somewhere at some time. And even if every definition collapses, that still holds true. So, is space-time real? Maybe the answer is no. But that question is proof that something is. And maybe that's all we need to keep telling the story.